Welcome back to Low Stress Math with Mrs. Bono. We are on Chapter 4, Solving Systems of Equations, Lesson 6, Determining the Number of Solutions to a System of Equations. Now, we've done a little of this before with graphing. When the lines are parallel and they never intersect, there is no solution. When one line gets graphed on top of another line, then every single point is in common, and that's infinitely many solutions. So we also know that when they have the same slope but different y-intercepts, that's parallel. When they have the same slope and the same y-intercept, that is the same line, so it's infinite. And we're going to start with that in the back of our minds while we start doing a little bit of figuring out just from the equations. Okay. In the last session, we learned how to solve systems of equations using substitution. Today, we will continue practicing that skill. However, in the last lesson, we only came across systems of equations that had one solution. Today, we will see systems of equations that result in one, infinite, or no solution. So let's start with this one right here. We are going to substitute, well, first, see how the n is all by itself, it's isolated? So that means that this second equation is solved for n in terms of m. So where that n is in the first equation, I'm going to substitute 3 minus m. And we also talked about putting that in parentheses. So parentheses around the 3 minus m, and that's going to replace the n in the first equation. So let's, 3m doesn't change, minus 2. That's going to change. Remember, minus is the same as plus a negative, because I'm going to be distributing the 2, and there's a minus sign in front of it. It really means I'm distributing negative 2. Now what am I going to distribute it to? Where the n was, I replaced it with 3 plus negative m. Remember, minuses become plus a negative for distribution purposes. Equals 9. So now, remember, I have to take that negative with my 2. So it's negative 2 times 3, and I get the negative with the m, and negative 2 times negative m. So 3m stays the same, plus negative 2 times 3 is negative 6, plus negative 2 times negative m is negative times negative, positive 2m, equals 9. Now I have to do some combining like terms. So I have 3m, and that is plus 2m. So 3m plus 2m is 5m minus the 6. Now, where's that pencil? Okay. To get from one side of an equal sign to the other, I have to do the opposite operation. Now, when they were both on the same side, I did the same operation, but I'm moving to the opposite side, so opposite operation. Plus 6 to both sides. I get 5m equals 15. Divide by 5. And m equals 3. Now that's just half of it. Remember, a solution to a system of equations is 2 numbers. It's an ordered pair. Now let's get the other number. So I need the n equals 3 minus m. N equals 3 minus 0. No, 3 minus 3. And 3 minus 3 is 0. So n equals 0. And it goes in alphabetical order. My solution in alphabetical order, mn, 3, 0. Puffy cloud of happiness. And that problem is done. Wait, I don't even have to say how many solutions it has, but if they ask to be one. All right, the next one. What would be the solution to this system? I don't know. Let's find out. This equation has the y isolated, So it is 7 minus 3x that's going to be substituted for y. Now, the y in the second equation does not have a coefficient. In other words, there's no number in front of the y. So I don't have to put parentheses around 7 minus 3x because I'm not distributing anything. Now, if this was a minus y, I would be distributing a negative 1, but it's plus y, so I don't have to worry about parentheses or any of that. Just straight up substitution. 3x plus 7 minus 3x equals 10. Now, remember, on the same side of the equal sign, you do what's there. So if I have 3x minus 3x, well, that's 0. 3x minus 3x is 0, so what's left? 7 equals 10. Well, that's utter nonsense. 7 does not equal 10, so put a little line through there. 7's not equal to 10. Remember we talked about this. When it's not equal, when the variable disappears and it's not equal anymore, that means there is no solutions. Now, I could actually have taken this second equation and done this. 3x minus y equals 10. 3x plus y equals 10. Subtract 3x from both sides and get y equals negative 3x plus 10, or 10 minus 3x, however you want to write it. And now let's compare that to this. Y equals 7 minus 3x. My coefficients are the same, negative 3x. My constants, 10 and 7, are different. That's parallel lines. Same coefficient, different constants, parallel lines. But since we're learning substitution, that's how we have to do it. All right, let's take a look at this one. What are we substituting? Well, here the y is isolated, so we are substituting 3x minus 5 for the y in that equation. And look, there is a minus here and a minus there. Both of those are going to be changed into plus a negative, so the distribution will look a little nicer. So I have 6x plus negative 2, and where the y is, I'm going to put 3x minus 5 in parentheses, 3x, not minus 5, plus negative 5. Remember, change those minuses to plus a negative to make it easier to distribute, equals 10. Nothing happens to the 6x, plus negative 2 times 3 is negative 6x. Negative 2 times negative 5, negative times negative is positive 10 equals 10. Oh, look at this, 6x minus 6x. 6x minus 6x is 0. 0 plus 10 equals 10. 10 equals 10. Now, when it's equal to each other, that means that it's infinite solutions. And I'm going to do the same thing I did before. I'm going to take this top one here, down to over here because I need more space. 6x minus 2y equals 10. I'm going to subtract 6x from both sides. And I get negative 2y equals negative 6x plus 10. Can't have that coefficient in front of the y, so I'm going to divide everybody by negative 2. And I get, well, that's 1y by itself. Negative divided by negative is positive 3x plus, oh, sorry, not plus. That's going to be plus a negative. So plus 10 divided by negative 2 is negative 5. Can't have double signs. Y equals 3x plus 5. But you're I am writing it again. I don't know, today is not my day. 3x minus 5. Make that 5 look like a 5. Because plus a negative is the same as minus. Wait a second. Look at that and look at that. Look, Look over here and look down here. It is the same equation. Remember, when it's exactly the same, that's infinite solutions. Puff cloud around here because I definitely have infinite solutions. This is sort of my way of checking it. When I get no solutions or infinite solutions, I get it down to y equals mx plus b, and then I compare. Same coefficient, same constant, same coefficient, 3x, so 3, same constant, minus 5. When that's the same, it's infinite solutions. Now back here, this was my check. I have the same coefficient, negative 3, and different constants, 7 and 10. That's how I know there's no solution. We'll do more with that later. Checkpoint, that's for you. All right, pause the video, look at your notes, and get that problem done. Pause the video, do the problem. Can't learn math if you don't do math. Okay, I really hope that you did the right thing and paused the video and did the problem. I am going to take this, because the y is isolated, I'm going to substitute 2x minus 3 for y, and I'm going to get, nothing happens to the negative 2x. There's no coefficient in front of the y, so I don't need to put that in parentheses. I can just write plus 2x minus 3 equals 1. Combine like terms on the same side of the equal sign. Negative 2x and positive 2x is 0. Minus 3 equals 1. 0 minus 3 is negative 3 equals 1. They are not equal. None of that is equal. So that means there is no solution. How can I check that? Well, I'm going to take this one, and I'm going to come over here. Negative 2x plus y equals 1. I'm going to add 2x to both sides of the equal sign to get it away from the y. Remember, these are unlike terms. You cannot combine unlike terms. And this becomes 0. Y equals 2x plus 1. And then I have this, which says y equals 2x minus 3. Same coefficient, different constants, no solution. That's a good way to check it if you're not sure. Just go back and put them both in y equals mx plus b. Okay, I think that is the end of that. Yep. Well, I will talk to you soon. Take care.